All right, so we're going to continue on with our lesson on parabolas. This first question on your worksheet for day 2, this is a warm-up from last week. So I need you to recognize which form we're looking at. Is this a horizontal or a vertical parabola? If it's x quantity is being squared, that is a vertical parabola, a normal one. So the formula for a vertical parabola is x minus h quantity squared equals 4 times p minus times y minus k. So if you kind of pull off all the important pieces, the first one's like an old skill for us, finding the vertex, which is always at h comma k. H is always paired up with the x and k is always paired up with the y. So h and k, just be careful this time because of the quantities being, in factored form, there's built-in negatives in both places. So the vertex is at 1 comma 2. And then the other thing I look for is this number in front of this quantity is equivalent to 4 times p. So kind of off to the side, I would set up a little equation, maybe over here, that says 8 equals 4 times p. So rearranging that, the value for p is 2. So that is the distance. That is the distance from the vertex to the focus, but also the vertex to the directrix. So what some people do right now is they go ahead and they plot that. I'm still going to find it with the formulas though. So let's kind of do a hybrid of both those methods. Let's plot and then we'll go back and use the formulas and make sure that we're in the right spot. So we have a vertex at 1, 2. And then if you told me it's a vertical parabola with a positive p-value, so it's going to be opening upwards. So that means the focus is 2 units above him. And the directrix line will be 2 units below that. Now I'm going to confirm all of those locations with my formulas here. Starting with the focus. The focus formula for a vertical parabola, I'm just pulling this straight off the formula sheet. It is, let's see, h comma k plus p. So using our information and a pen that works, come on pen. Here we go. H and k, remember, are from your vertex. So that would be 1 comma and then 2 plus, we just found p to be a 2. So of course that simplifies to 1 comma 4. So according to my calculations, I should have a focus point at 1, 4, and that's exactly where we plotted it when we looked at the visualization of the distance for p. So go us. Keep going. Directrix line, that's another calculation for you, although we do already have it graphed. The directrix line formula is, for a vertical parabola, is y equals k minus p. So for you guys, that would be 2 minus 2, which is why we graphed a directrix line at y equals 0. So everything we graphed from the visualization of it, I confirmed with my formula. So that's a good way to maybe approach it on your test for sure. We've like double checked ourselves. There's one more thing we don't really have to calculate because it's pretty obvious once we get it graphed, but the axis of symmetry is going to split straight through the vertex. So the formula off your formula sheet for a vertical parabola says the axis of symmetry is x equals h, which for us would be x equals 2. Now when I graph, no, that's not h. Isn't it 1? Okay, x equals 1, which I was going to fix because when I went to go graph it here, x equals 1 is the line that would split through. That's supposed to be straight, sorry. Okay, so now the fun part, because you have to graph. You're going to need one good point that you figure out because of your formula, and then we're going to use the laws of symmetry of a parabola to figure out another point, and then we're going to do our best to graph. But this is the fun part, right? Right. So you go to this original problem setup, and I need you to rearrange it so that the y is isolated. So there's 2 things you're going to have to do to isolate the y, and you want to do them efficiently. So to get rid of the h, I would multiply by 1/8. That's the easiest way to move this over here to the equation. So multiply by 1/8 on both sides, and then the final step is you're going to add this 2 over to the end of it. So what did I just say? We are going to multiply by a 1/8 over here. And then because over here it says y minus 2, I'm going to add the 2 over. So that was you guys actively rearranging the formula for that singular variable that's hiding somewhere in there. Because now when you go to give a point, I want you to kind of think brilliantly about points, although we did learn that it doesn't actually matter. As long as you're not giving me the vertex again, you can probably give me any point you want, just make sure it's not too crazy. But I think you guys can do this. If you could make this quantity a 16, because that would be a perfect square that's divisible by 8 real nicely, that would make me happy. So what number would you have to plug in for x to make this quantity right here 16? A 5, very good. So if you plug in x equals 5, you get 4 squared, which is 16. 1/8 times 16 is 2, 2 plus 2 is 4. But, you know, we learned on Thursday, you can technically plug in anything. Let's see, 1, 2, 3, 4, 5, 1, 2, 3, 4. And then because of the symmetry of a parabola, if this is 1, 2, 3, 4 units out from the axis of symmetry, you can go the same distance over here. And then you draw what is sure to be a beautiful parabola. Oh boy. That's decent. I'll take it. And that's what we did on Thursday. So today's going to be a hoot because it's day 2 of this lesson. So that means more exciting. Let's look at number 2. Notice any problems? Does this look like your formula sheet formula? Like at all? No. So you need to make this look like your formula sheet stuff. First thing I'm noticing is that we don't have any quantity being squared. So when that happened in the circles lesson, that means I had to complete the square. So I have a little bit of good news for you. You only have to complete the square once because you only have one factor that's being squared on parabola. So here's what I would suggest you do. And this one's a little strange because of this guy right here. Technically speaking, this is ready to factor into y plus 3 quantity squared, but that's not usually the way these problems work out. So just for the sake of consistency, let's pretend I didn't notice that. What I would expect you to do is keep just the y terms together and get everything else away from them, basically. So I would expect you to subtract 9 over here, even though we realize that's kind of silly, but do it anyways. So y squared plus 6y. We're going to complete his square. And this is where I like do a mental head slap. I'm like, oh, duh, I already had it. Equals, now remember you subtracted this 9 over. It doesn't really matter what order you write them in right now because we have a lot of rearranging to do. So I'm just going to say 3 minus 12x for now. But because we're completing the square, whatever you add over here in the blank, you have to also add over here. And this is where I go, oh, duh. Because what goes in that blank? A 9. Half of 6 squared would be a 9. So that was kind of silly of me because I just undid my work, but whatever. So the y squared plus 6y plus 9, that factors into y plus 3 quantity squared. And then this stuff over here, I just need to collect the 9 and the 3 together. I'm going to make that a 12, obviously. However, if I look at my formula sheet, I'm trying to match the formula sheet exactly. So I'm going to put the x term first. And then I'm still staring at that formula sheet, and I'm a little disappointed because this does not look like my formula sheet. My formula sheet says y minus k squared equals 4 times p times x minus h. So you're going to have to do some manipulation over here on the right-hand side to make it look like this. So in other words, you're going to need to factor out some magical number that apparently represents 4 times p. So what could you factor out of this expression? That would be a common term. And think like as algebraic as possible. A negative 12 would be like your gut instinct, and that's what you should go for because you don't want your x to be negative. So if you factored out a negative 12 from here, this quantity becomes an x minus a 1. And then you haven't really done anything over here to the left side other than you've completed the square so you could factor it. And now I totally look like that formula. So now we're back at where we started on Thursday. So think about all that fun we did on Thursday. Now we get to do it here. Okay, starting with what kind of parabola is this going to be? It's going to be horizontal. So a little note to self that you have a horizontal parabola. And an old concept, let's bring it back. Where's the vertex located? Remember, it's at h comma k. So h is over here this time, k is over here. and you have built-in negatives in both places. So your vertex is at 1, negative 3. Little calculation on your part. Negative 12 is supposed to represent, remember the formula is 4p. So solving for p is negative 3 units. That's very important to my graph, but also my formulas coming up. Now, on the last question we did, we went ahead and graphed some things, and then we kind of confirmed them as we found them. I think that might be a good approach for us here. I'm going to plot my vertex at 1, negative 3. Now, because the p-value is negative, and this is a horizontal parabola, which direction is it going to open? So they normally open to the right, so if it's negative p, it's going to open to the left. So the focus, because it's going to open over here to the left, the focus is 3 units this way, so there's going to be your focus. And then your directrix line is 1, 2, 3 units this way. Whoopsies, now it's straight. Oh, that's terrible. Okay, so now all those things I just drew, I'm going to go ahead and I'm going to calculate them and double check that I've done everything okay. Let's start with the focus. So on a horizontal parabola, make sure you're looking at the right formula. The focus point is h plus p, comma k. So plugging in things that we know. What's h? H is 1. The p you just found to be a negative 3. And then the k value is negative 3. So when you simplify that for me, you get a focus point at, let's see, negative 2, negative 3. Now, remember, we already graphed the focus point. So let's do a little confirmation, make sure I didn't do anything weird. Did I put that little green star at negative 2, negative 3? Awesome. All right, we're on the right track. Directrix line. For a horizontal parabola, it is at x equals h minus p. So using our numbers, that would be, where's h1 minus negative 3. Of course, you're going to simplify. So that gives you a directrix line at x equals 4, which I already drew. So let's just kind of double check that I actually do have a directrix line at x equals 4. Kind of, yeah. Supposed to be a 4. And then the easy one is the axis of symmetry, goes through the vertex. So that would be y equals k value. So for us, that would be y equals negative 3. I haven't drawn that one yet, but it would be right here. Oops, no, it wasn't right there. Now for everyone's favorite spot, you get to rearrange your formula. So I need you to go back to this version of the formula right here, the one where we finally got it to look like this conic form that we've been looking at. And I want you to solve for x. So there are 2 steps that you have to do to solve for x. You got to, quote, get rid of the negative 12. So we're going to multiply by negative 112. And then you're going to add 1 to the other side. So this formula, rearrange, you'd multiply by negative 112. I lost my formula. Then it's y plus 3 squared, and then plus 1. Now be careful, because you're graphing a horizontal thing, this time you're coming up with y values to plug in as your input. So you got to think about, okay, I'm going to multiply the squared factor by a negative 112. So if I can make this thing a 36, like that would be really nice. So if this was 6 squared, that would be a y equals 3, right? If you have a hard time coming up with, quote, a good point, just get a point. I don't care what it is. Just decimals are fine. They work fine. So plugging in a 3, let's see, that's 6 squared, which is 36. Negative 112 times 36 is negative 3. Negative 3 plus 1 is negative 2. All right, back here. I already forgot what it was. Was it negative 2, 3? Okay, cool. Negative 2, oh boy. So if you think about symmetry across the axis of symmetry, you're 1, 2, 3, 4, 5, 6 units up from it. Now you got to go 1, 2, 3, 4, 5, 6 units down from it. And you got this fat parabola. Oh boy. But you know, when you think back to your formula, this was like an A value equivalent of -1/12 from like our previous knowledge of parabolas. That is a very wide parabola, so that makes a lot of sense. Hey, that was pretty good. Look at that parabola. Go me. All right, I'm gonna save these slides. We were just commenting on first hour. We're like, what about those poor kids who are gone today? And they open up the slides and they look at that and they go, oh, great. All right, absent children. All right, moving along. So it's going to be more of this. We're going to do a little skipping though. I'm going to make sure I don't skip the one that I didn't skip though. Hold on. And the vertical one. The next one's another vertical one. They're all kind of exciting. Let's go ahead and do 3, and then we're going to skip to the back. So, number 3. Definitely not in any form that I recognize on my formula sheet. So we're going to have to do some completing the square. This time you're going to complete the square with the x's. So I'm going to bring my x terms all to the left, and everything else needs to move. So rearranging it a little bit, let's add the 6x over. We're going to complete the square, so leave it blank. And then remember, you're going to move the 21 over. You're going to subtract 21 over here. So let's see. I'm going to write the -20y first. And then this is -89. And I got really nervous first hour when I did this question because I thought I was going to have to factor a 20 out of a -89. But then I forgot that I didn't balance my equation yet. I got this plus blank here. So then I breathed easy after that. What goes in that blank? It's going to be 9 again. Yeah, that's kind of coincidence that they ended up being the same completed square, but it happens. So this is now going to factor into x plus 3 squared. And then this, when you collect your like terms, you have a -20y minus 80. But again, you have the issue of, well, this doesn't quite look like my formula sheet. So do a little factoring here. What can you factor out of this expression so you can pull out that 4p value? A -20 would be brilliant, which changes this to a y plus 4. It's a little depressing because now I realize that I've just now started my problem. Here we go. Where's the vertex? HK, so it's -3, -4. Very good. Built-in negatives in both places today. Little calculation for us. -20 is the value of 4 times p. So solving for this one, that gives you a p value of -5. Which means this, oh, I forgot to ask you, is this a vertical or horizontal parabola? This one's vertical because the x is being squared. So if you want to start plotting things, you can. Vertex being at -3, -4. Now, because p is -5, what direction is this going to open if it's got a negative p value? It's going to be opening downwards. So the focus point is 5 units down from that vertex. And the directrix line should be 5 units up from the vertex. Let's go confirm all those things with our formulas, though. All right, focus. Focus formula is, let's see, for a vertical parabola, it is, nope, not that. It is h, comma, k plus p. So for you guys, that would be h, which is -3. And then k, which is -4, plus p, which is, oops, careful, -5. Watch your negatives on this one. This is why I like to graph and then also confirm the formula, because if you have a negative mistake, you're going to find it here. Hopefully. So this focus point comes out to -3, -9, which I think is exactly where I plotted it. This little green star down here was at -3, -9. So let's talk about the directrix line. For a vertical parabola like this, the directrix line is y equals k minus p. So for us, that would be -4, and then minus a -5, which simplifies to y equals 1. I think that's exactly where I drew my Directrix line. If I go check. Yeah. So far, so good. Axis of symmetry is straight through the vertex. That's a weird F. Axis of symmetry would be x equals h. So for us, that'd be x equals -3. I have not drawn that yet. But here it is. And then now for the fun part. I have to go find a point. Going back to this version of the formula right here. I need you to rearrange that guy by solving for y. So there's two things you're going to have to do. You're going to have to multiply by -1/20. That'll knock out the 20. And then you're going to have to subtract 4. I don't know. Yeah. -1/20 is now in front of the x plus 3 quantity squared. And then we're going to subtract the 4 over. All right. Good news, this time you get to plug in an x. Oh boy. If you could make that parenthesis thing 100, that'd be awesome. So what would you have to plug in for x to make that quantity squared 100? 7 would work. Yeah, 7 plus 3 is 10. 10 squared is 100. Okay. So 7, that would be 100 times -1/20, which is -5. -5 minus 4 is -9. Oh boy. I think we're going to fall off the graph a bit here, guys. For instance, 7 is over here. And something going equally as far out would be like over here, in the middle of my work. Sorry. Oh, absolutely gross. Okay, and getting worse. That parabola is large and in charge. But guys, look at the a value. A -1/20 in front of a parabola. Yeah, that'd make it pretty stinking wide. It's a very tiny a value. Okay. Has anyone figured out what like real life application these might have? Anything in real life, like for a normal human, you may have seen that looks like a parabola? Not sure what he said, but maybe I don't want to hear it. Someone said St. Louis Arch last hour. Oh, rainbow. Yes, rainbows are. Take that. I don't know. You giggled a lot at it, and then I got nervous that he was like saying something I didn't want to hear. So satellite dish. Yeah, it's a parabolic trough. And like you guys might think of the ones that are on top of your house or someone else's house, but like the big ones out in space, you know, like they have receiving points where like signal has to come in at this point. Well, that happens to be the focus point, so that's kind of cool. There's some really cool application questions that no one wants to do about that. No, nobody. Okay. On the back. Let's take a look at. Okay, so 5 is a little boring because 5 is a lot like what we did on our notes, like from the previous lesson. The last question in last night's homework was probably the most challenging one because they didn't give you the vertex. So if you guys figured it out through graphing it, that's awesome. Otherwise, like when we did it together in the first hour today, we ended up with a system of equations that was kind of cool. So if we have time at the end of our lesson, I can go back and do that one. But let's look at number 6 for sure, because 6 is a good time. So you notice that they do not tell you in number 6. They don't tell you the vertex, which is kind of an important piece to my formula. So they tell me a focus, and then they tell me a random point, and there are definitely ways to get around doing all the algebra and the substitution. You can look at the graph and really figure it out as long as the p-value is nice. But they're not always nice, and frankly, I don't know if that's an efficient use of your time, especially if you graph like me. So instead, let's look at the clues they gave me. It opens to the right, so it's going to be a horizontal parabola with a positive p-value. I'm going to write myself a little note. Positive p-value. The focus is 2, 1, but what's the formula for a focus on a horizontal parabola? It is h plus p comma k, isn't it? I always get these backwards, so double check me. H p comma k. Yeah. Now, when they give you this random point it contains the point 8, -7. This is called a point from your locus, which is just the collection of points along the parabola itself. So this is just a random ordered pair, which you are going to refer to thusly as x and y. So we have an x, we have a y, we have some stuff that talks about h and p and k. Your job is to put things where they belong into the formula. So first of all, let's look at the actual formula itself. If we have a horizontal parabola, the formula we're looking at is y minus k squared equals 4 times p and then x minus h. So let's start filling in what we can figure out. Starting with, I think you know a y value, guys. Right here, it said y can be -7. So you go, all right, -7. Minus. Hey, I think you secretly know k. It says right here, k is 1. I have no clue what to do with the value for p right now, so let's just leave it as 4 times p. So let's just agree, p is our variable for this problem. Okay, x, it says right here, use 8 for x. Okay. And this is where it gets a little exciting. We don't have an h, but we kind of have an h. It says right here that 2 is h plus p. So could you do a little rearranging and tell me what h is? You subtracted the p over here. 2 minus p. So what you're going to do is you're going to have 8 minus, and then because it's a quantity, you need to use another set of parentheses, and instead of saying h, you're going to call it 2 minus p. Oh boy. Now, I know that doesn't look really good to you guys. You're like, that looks horrible. What I'm noticing, if I kind of step back and look at it, you have an equation, a lot going on, but there's only one unknown thing in it. There's a variable p. It does show up more than once. If you look ahead, we will have a quadratic, but it's okay. We're PreCalc. We can handle a quadratic. Here we go. This is -8 squared, so that's a 64. Just going to leave that as 4p for now. Now, careful when you go to simplify this part. 8 minus 2 is obviously 6, but then you have a subtract -p. You have a plus p. Do you guys see the quadratic developing now? Your instinct right now is to multiply everything, like distribute that 4p, which is how most kids do this question. Does anyone have another idea, though? If you don't, it's okay. I'll bring it up on the next question. Okay, let's distribute the 4p. So this equation becomes 64 equals 24p plus 4p squared. Oh, there's your quadratic. You guys need to get this into quadratic standard form. So everything to one side, and then I do notice kind of something nice. Do you notice how everything can be divided by a 4? So let's do kind of those steps all at once. I think you guys can handle it. We're going to divide everything by a 4, and I'm going to rearrange it so everything's on one side and it's in standard form for a quadratic. So this guy becomes, let's see, 0 equals, this will be a 1p squared. This will be a plus 6p. And then remember, guys, you're going to be subtracting this 64 over 4 over, which is a 16. So it says minus 16. Fun is not over. You got to solve your quadratic now. Let's see. Multiplies to -16, adds a 6. Let's do p plus 8 times a p minus 2. And then you're probably like, oh, fantastic, 2 answers. But one of the first things we wrote down at the very beginning of the problem said it opens to the right, so your p-value has to be positive. So look at your answer choices. Think you're going to keep both of those? That guy's that's extraneous, essentially. You can't have a p-value of -8 if your parabola is going to open to the right. So p-value is 2. And I bet you think you're done. Hey, you're not done. We have to actually write the equation now. Good news. You have everything you need. You need the value of p. We have it. You need the h and the k. So using your h and k, which is your vertex. Did anyone catch where the vertex was? It should be at, I forgot what number we're. Let's see. So h, oh boy, that's a formula, huh? It's 2 minus p. So 2 minus 2 would be 0. And then the k value, I think they just flat out told us somewhere in our work, k was 1. And then we just found out that p is 2. All right, guys, plug them in. So that original x and y, the locus point, you don't use that anymore. What do we have here? So y minus 1 squared. And then 4 times p would be 4 times 2, so 8. And then I have no problem if you guys just say x minus 0 just for the sake of consistency and then leave it like that. But what would a normal human write? They would just write x. Yeah, they wouldn't say x minus 0. But we aren't normal humans. All right, so there's that question. That was a hoot. Let's do another one of that. Let's do a vertical one. Try number 7. We're going to skip 8 simply because of time. So if you need extra space, you can use number 8. All right, so number 8, we have a very similar question, but this time they're telling me it opens downward. So that clue is going to become very important to us when we get to the quadratic step. If you have a vertical parabola who opens down, that means your p is negative. So keep that in mind when we get to that part. They give us a random xy ordered pair. That's going to be helpful in a minute. And then they give me this clue about the focus. So if the focus is at 1, 4, and I go back and I look at the formula for focus for my vertical parabola. Focus for a vertical parabola is h, k plus p. So I know some things. Right here, I can tell you that h is 1. And right here, I could tell you that we're going to have to substitute some algebra. So k plus p is equal to 4. So if you rearrange that a little bit, you find out that k is 4 minus p. So we learned from our last example, like we're going to have to come back and get h and k. So kind of make a big deal about those, put a box around them. We're going to have to come back. But I think we're ready to start plugging some things in. Here we go. You might want to start by writing down the actual formula. You have a vertical parabola this time. So you are, oops, wrong color. You're looking at x minus h squared equals 4p times y minus k. So you have an x, you have a y, you have an h, you kind of have a k, and p is going to stay as a variable this time. Bless you. So x, what was that random x value they gave you? -3 minus h, which they just flat out said was a 1, quantity squared equals, I have no idea what p is, so it stays as 4p times, they told you a y value from your ordered pair here. And then you're going to subtract k. But again, k is not like a number, it's an expression this time. K is 4 minus p. All right, so a little bit of cleaning up. I'm going to show you a little shortcut though. -3 minus 1 is -4. -4 squared is 16. Cool. Leave the 4p for a minute. 1 minus 4 is -3. And then careful with the double negative. You're subtracting a negative p, so that's plus p. So I know in the last question we went ahead and distributed the 4p, and then we were like, oh, yikes, a quadratic. And then we had to divide, and then we had to clean it up. I mean, it's not a huge time saver, but guys, remember, after we distribute this, you're going to go through and you're going to divide by that 4. So there's really nothing wrong with going ahead and dividing by 4 right now, as long as you do it to both sides. So, I mean, not tremendously better, but a little better. So now it's 4 equals p times -3 plus p. So bad news, you still have a quadratic. You still need to rearrange that quadratic for me. But the good news is it's pretty easy to rearrange now. Just subtract the 4. All right. So factoring multiplies -4, adds a -3. That would be a p minus 4 times a p plus 1. However, just like in the last, question, you are going to have one answer that you need to throw out. Do we have a p-value of 4 or a p-value of -1 for this one? Yeah, P has to be negative according to our little note up there. So P equals 4 is no good. P must be -1. So now I got to put all these thoughts together, guys. I have H, I kind of have K, I definitely have the P. Now let's go back to our formula. Oh boy. Whew. X minus H, so X minus 1 squared equals 4 times P would be 4 times -1, so -4. And then Y minus K, well remember, K you have to kind of sort of calculate, so 4 minus -1 would be a 5. And notice I kind of forgot to graph the last two questions. That was just out of laziness and out of my lack of time that I had left. So you guys could totally graph them. I know you could. We've been graphing them for days. Moving along, let's look at some applications. You'll be pleasantly surprised to hear that the applications of these are actually much easier than the questions we've already done. Because when we hit these application questions, we're going to do something kind of cool, which is where you're going to superimpose a coordinate plane like onto the application itself, which allows you to choose where you orient the coordinate plane. So like if I had it up to me, I would make sure that my vertex was always at the origin, because that would make for really nice math. So that's what we're going to do. You have a satellite dish, and the receiver is inside of the parabolic dish. It's 2 feet from the vertex, the bottom like dip of the parabola. So you've got the satellite dish, whoop, and I'm going to superimpose a coordinate plane on it. So since I'm lazy, I'm going to be like this. That was supposed to be at the origin. It didn't really make it. So his vertex is going to be at 0, 0, according to me. And then that clue about the antenna being 2 feet above it, well, that's the focus. So if this is your focus, I think they secretly told you a very important clue to our equation writing. How large is P? Yeah, it's just 2. P is the distance from your vertex to your focus or your vertex to your directrix. So if it's 2, it's 2. So you have an H, you have a K, you have a P. I think we're ready to come up with a formula. So we have a vertical parabola because of the way I've oriented it. So we have, what do we have? X minus H, boring, squared, equals 4 times P. So 4 times 2 would be 8. And then Y minus, that's boring. How do you think a normal human would write this? X squared equals 8y. Or if you're an algebra 2 human, you would divide both sides by 8, and you'd get 1/8 x squared equals y. Either way, you got a fat parabola. I mean, think about all the satellite dishes you've seen, guys. They're not very narrow, right? They're big old shell-looking things. Pretty wide. And then this next one, bit of a lame example, but it's the same idea. And someone earlier in the day brought up the St. Louis arch. That is a good example of a parabolic trough. In fact, I remember being in St. Louis a couple summers ago, and there was something about the parabolic trough as you ride up in that weird little thing. So do the math when you go there. Do the math. All right, here we go. Write an equation that models the parabola. So we have this arch, very cool. We're going to choose to orient it however we want. So of course, I'm going to make this be the origin. And then I'm going to do a terrible job of graphing this. That's okay. Down 10 over 20 each way. You gotta, oh man. Okay, kind of. You have that parabola. And the fact that it is 10 feet from here to here, oh jeez, it's ugly, tells you something about your parabola. It tells you that this, because of the equidistance of the symmetry here, this guy right here must be your focus point. So your focus point is down 10 feet from the vertex, which we are conveniently calling vertex as 0, 0. Talk to me about the value for P on this question. I know it's 10 units, but because it's opening down, what else do you know about the value for P? It's -10. Very good. So vertical parabola was 0, 0. So what do we have? We have, I'm going to skip the -0 part this time. X squared equals this guy times 4 would be -40. And then I'm going to skip the -0 part and just call it times y. Ta-da! The applications on these are awesome because you choose to superimpose where the orientation is from the origin. Yeah. inside. Remember, focus parabola hugs it. So 2 feet above it, it would look like that. Yep. Does that make sense? Okay. All right. So you guys have another secondary book assignment. I know that last question on last homework assignment was a little tricky. I think you'll be able to figure it out now, though.